for us to share what Ido has created and show how he has done it and how he has extended the Ktor framework for his needs. And but before we go to the meat of this session, I want to share a few news by the team because we are talking about Ktor today. So the news are by the Ktor team. Um, there are a few articles on the blog. If you go to Kotlin blog, you will find them. What I wanted to share here is that Ktor team just published a roadmap for the next version, and there are a few interesting things they have announced, especially the integrations with various frameworks and libraries, including OpenTelemetry and gRPC. The other things include their plans for changing the I/O functionality in the framework, and also they are going to introduce support for managed transactions and DI, which was a little bit controversial by looking at the discussions on Twitter. Well, there is an update to that. So it's not like there will be an opinionated version of DI in Ktor or anything like that. It's just a way to integrate into the framework itself. And another interesting thing that is mentioned also in this roadmap, but is actually live already, and there is a dedicated blog post about that, is the new plugin registry. So when you use the project generator at start.ktor.io, the basically the same backend that is used in IntelliJ IDEA for creating the new projects, there is now a way to submit your plugin to Ktor plugins registry so that the project generator will pick it up, and your users or users of Ktor framework will be able to just generate the projects with the plugin included. I can briefly show that. Start.ktor.io. If you go there and we add plugins, so for instance, there was exposed, well, there wasn't an exposed plugin. Now it's actually included, exposed, right? It's right here. And the way to submit your plugin to the project generator is to go to this repository in GitHub and submit a pull request with the metadata describing what your plugin is. So basically, you don't have to submit the binary anywhere. You just submit the metadata, where the binary is, what are the coordinates, and so on. And the project generator will be then able to pick it up. So we already have a few pull requests. So if you wanted to see how to structure it and how to submit it, there are a few examples already. So this MongoDB plugin is already submitted by someone, but it's not accepted yet. So there is a review procedure. Our folks will review the plugin. How does it look like? And then merge the PR into the registry. And then after some time, it's going to be in the project generator. So that's one way for you to promote your interesting plugins and make them more available to the developers who use Ktor framework. With that, I want to hand over to Ido and start talking about the awesome plugins he has built.
Thanks, Anton. Actually, I think it's a perfect segue to this, because now that I see this registry, I'm definitely going to submit my plugins there. But I guess, yeah, you want to say something, Anton?
Yeah, I did my best. I mean, I wanted to introduce you and make this segue into the plugins. But yeah, Ido, could you introduce yourself and tell what you do at your daily job? And obviously, it's not like full-time building the plugins. And where did the need come from? And tell us your story.
Yeah. So my story is basically I started as a Java developer, backend engineer. When I found out about Kotlin, I quickly moved to it, and it was a very easy transition, and I found it very pleasant as well. And but like at first I was still working in places where we were working with like frameworks like Spring, where you would basically write Java code in Kotlin. Like you would still write it in the same kind of code that you write for Spring using Java, but with Kotlin, but still in that same kind of like Java mindset. Later on, I moved to another place where we actually did everything like with Kotlin and the Kotlin ecosystem. So that's where I met Ktor for the first time, and it was such an obvious difference that like when you do that, you actually use Kotlin to its full capabilities, and like you're not confined to this the paradigms that are dictated by Java, and it was just way more idiomatic and like beautiful. I don't know, I can't really explain it. So, but the thing is, I think that like what I noticed in the market is that still a lot of companies, even if they like use Kotlin as their main language when they work with the JVM, then they still use Spring, which is the case that I encountered at first. And I think the reason for that is basically because there isn't yet enough functionality that's provided by Ktor, whereas with Spring, you have all these plugin starters that have been developed over a very long time and are trusted and what's the word, that tried and trusted, whatever, that have been used for a long time,
Yeah.
and they provide all the kind of established, yeah, tried and true, whatever. So the all the functionality that a backend engineer, systems engineer would need are kind of existing already. So that I think is the reason that like people or companies are still sticking to Spring. So the goal, the kind of the motivation behind my project. So this is just like my GitHub repository here with different projects that I work on in my open source stuff. But so this is the page for this repository for the Ktor plugins that I've been working on. So if we look here at the motivation, basically saying what what I said before. So the goal here is to provide more functionality that is missing right now for Ktor that is usually available in Spring Framework or others. And now that we have this plugin registry, actually, it's that would be the perfect. It's not really a repository, but a registry. So, in this repository, the goal for me was to kind of like follow the design patterns that I've seen the native Ktor plugins are written with, and kind of follow them in terms of how the code is written, how it's structured, etc. So we'll see all that in action soon. You want to say anything, Anton?
No. I was nodding. Like, all good,
Okay.
all good.
No, I'm just like talking for a long time, so I feel like yeah.
No, it's okay. It's okay.
Okay, cool. So I mean, we can look here at the homepage here, like the kind of like different plugins that I've developed so far. So we have like a plugin for Kafka. So this is not a low-hanging fruit, but like the low-hanging fruits are actually like the rate limiting, which is actually already provided natively by Ktor. When I say natively, I mean out of the box. But this one provides like different algorithms for it, and I don't know if it's better, but it provides more flexibility. We have also the circuit breaker for the client, and like again low-hanging fruits. And then these are kind of like more higher level, I would say, the Kafka and task scheduling. So the goal here is to kind of like provide the same functionality that, again, Spring Boot provide for managing systems, for managing communication between different instances, and managing load and etc.
Did you need to use those plugins in your projects as well? Like when
I've so for the Kafka one, like I've done some work that inspired this. So it's not like there's no code that's common to them, but it was like learnings basically. And
I see.
no, this is because this I've done in my own like on my own open source stuff, and like right now I'm doing more blockchain and plugin development, so I'm not actually implementing this at live, but I've tested them. So yeah.
Yeah, I can tell that as much as I have been talking to Ktor users, it seems that the scenario when you have to use Ktor with some external, I don't want to say message queue, but middleware to make the system fully asynchronous is quite a common case. And I think I have seen 3 or 4 different implementations of how people actually implement the communication from Ktor to Kafka. And one of them, I think a couple of years ago, we actually hosted a webinar with Viktor Gamov. He used to work for Confluent at that time. And it was like a different approach from what I have seen in your repository. But that's what it makes interesting, right? You have a choice doing it one way or the other way. Which one do you prefer?
Yeah, I mean, this was actually that webinar that you did with Victor, was it? Was kind of inspiring for this. So this was kind of like the inspiration. It was like, because I saw it was done, but like half baked. Like it seemed like it was done for the purpose of the demonstration, but it wasn't like a plugin. So I kind of relied on some stuff from there. So that's also acknowledged here. Yeah. So what I did for
I think we could look into your plugins now, like one by one, or like how do you would like to show them? Probably you have some demo for us, right?
Yeah, so I have like a demo project that I prepared for like a system, a simple system where we would want to actually use these plugins. So that would be a good intro into how we integrate these plugins into the system, what needs do they answer, how we configure them, and through that we can also have a look at the code of the plugins themselves. Right now we can see like that's in the readmes here we have like basically instructions on how to install and configure, relevant for all of the above. So this all of this you would be able to see once you visit the repository. But for now, let's start maybe with some live coding.
Sure.
Yep.
Show us the code.
I'll do that. So what I did here is basically I created like a simple system that we have a producer backend that produces events. We have a consumer backend that consumes those events, stores them in some data structure, and then we have a client that is asking for those events, for the records of those events from the consumer. So let's start with the producer. I'll just open it up here. You'll notice that I actually configured this one with like the Ktor configuration for this one is in file. For the consumer, it's in code. We can see that the same kind of different methods are applicable also for the plugins normally. So, for example, if you look here, resources, we have a YAML here, and we just give it the port and ID. And now we can close this. So let's have a look at the producer. So what we have here, a module for the producer. And what does it do? It produces events. What is produce events? It basically does this. So we subscribe to the application started event from Ktor, from the Ktor internal engine. And we log something, and then we just started a coroutine, and we, in a loop with some frequency, we send an event, which is basically this. We say we're sending an event. We don't have the infrastructure for sending that event yet, so we'll get there. So now the question is, for now, just to kind of like have a quick kind of look into plugin development to see how kind of easy it is, maybe, or like how fluent the API is. We'll do the production of events. We'll do that with a plugin. This is not the way to do such a kind of limited functionality, because it's kind of like provided out of the box, like as a function. But if you would want to maybe extend it, then you could do that with a plugin. So let's go ahead and do that. So what we're going to do is create a plugin. So event producer plugin is a create application plugin, and we say event producer plugin. And then what we do is we do something very similar. Okay. So we just go on application monitoring event from the server, application started. And here we'll just basically copy paste this. And we just say this is an app. Now here, like here we pass the frequency as a parameter to the function. But here we don't do that because it works differently. Like the plugin is a value. So how do we do that? Then we create a class, event producer plugin, configuration, config. And we basically give it that argument. Now, it's important that like for configuration classes for plugins, we have them as vars and not as vals. That's because the way we configure a plugin is by passing a lambda, which is a modification of the configuration. So how do we do that? If we go here, event producer plugin configuration, let's just format this. So we pass it this lambda, basically the creation of this configuration class. And then we can see that the type of the application plugin changed to that. Like if I remove it, we'll see that it's nothing. But if I put it here, we see that this is the type that the type of configuration the plugin is using. And then that configuration would be available to us here in plugin config dot frequency. And now we can do that. That's like this.
From the first sight, it feels like some sort of a magic, right? How you can with so little syntax actually create such a construct. What I like very much about this approach is that it's how easy it's to create a plugin. I mean, you don't have to package it. You just have it as an extension to something, and it's just a variable. It's just a value.
Like, and it's all like
you just created it, and it's there.
Yeah, there's no annotations or anything like that. It's just it's all compile time, basically. Like
exactly.
And the type system.
A few other remarks. The syntax colon, and then the class name or the type name. Some people might not be familiar with that. It's not just a lambda. It's actually a callable reference, something that we have in Kotlin for functions and also for the constructors. The other thing that we mentioned here is this block of code that follows create application plugin function call is it like a function? No, it's not a function. It's a parameter, right?
Sorry?
I think if you go to create application plugin, if you go to the definition, there will be this body plugin for the plugin builder, and that's the lambda with the receiver. So that's the lambda that is getting executed that mutates the configuration values, right?
We'll see this a lot in the code for the plugins.
And the code that you showed previously was that, well, wasn't the plugin, right? It was just a
Yeah.
function that we could just create. And it might seem at first glance that we just created a plugin for the sake of creating the plugin, and it might feel like it's a hack, but no, no, it's actually a real thing because it's a real public API for subscribing on the events, and there is a monitoring event in Ktor available. So it's a totally legit approach of creating this kind of functionality. If your application starts up and you want to provide a plugin that on the start will start doing something continuously, that's totally legit.
Yep. I think like as I said, I would say that like if it's a very simple configuration that you don't really care about encapsulating and moving around, then this approach would be, I don't know if easier, but less complex. But in this case,
Yeah.
we see that like if like for example you have a lot of configuration that you want to do here, then it makes sense to do that in this way. And if you want to make it more abstract and then like reusable by different consumers, then you do that. I just wanted to show here maybe what you said about this. I think this should be just the function reference. Yeah. So okay, now let's just actually use our plugin instead of let me just do this. Cool. So we're gonna switch over to producing events using the plugin, which will demonstrate also how we like install a simple plugin. So let's go here and remove this. Install event plugin, and then so now if we do that, then it's just like, okay, this is the plugin that you defined with the default configuration. But if I do this gives me access to the configuration. Like you can think of this part is basically this. Like what it is a lambda that accepts the configuration as the receiver and returns unit. That like
Right.
that pattern is very common in plugin development with Ktor, because this is how you pass configurations. You define a configuration, and a lambda that is a invoking of that configuration will always be receiver dot nothing to unit. Let's see here.
Something to mention as well, maybe to highlight a little bit here, is that it's not enough to drop something into the class path for the application like we have in Spring, right? It's very often that you add a component as a dependency in Spring framework and then you get a new behavior. In Ktor, it's not enough. You add a dependency or you have some code in your class path in your project, it will not trigger automatically. You have to be explicit about your intent of using this plugin or this functionality. Therefore, you have to call it, or like you have to pass it into this install function and to make sure that it will, start working.
I think that relates also to the compile time versus runtime stuff in a way.
Yep.
And the because not without using annotations and everything, like I think it's also a better behavior because you're more explicit about what you want to activate, whereas with the Spring starters you just have some magic in the background. So here, so we can say that our this dot frequency equals frequency. I can also say frequency if I rename this to and then it's maybe nicer. So now we have a producer that produces events. Let's see how it does that. So maybe we can go here and just run the producer. And maybe look here. So we see, okay, it's sending events, and like it pretends to be sending events because we don't actually do anything in that function, but we can see that it does that in the frequency of every second. Cool. So now we're going to stop that. And let's close this. And now the second question is, how do we set up event publishing? So we want to send those events. We need some to send them somewhere. So I mean, this is where we want to kind of put in Kafka. So let's look at that. Then what we need to do is we need to set up, like define Kafka, define the clients that this server is going to use to communicate with Kafka. And then we need to invoke basically the producer for this one. So let's go ahead and do that. So we'll go down here and we'll close this. And let's just create another fun. This is also kind of like the pattern of, I mean, this is something that you see already when you start developing with Ktor, is that any functionality that you add to the application is like extension functions on the applications. So like this, but what we want to do here is configure Kafka. So we'll do install. And I already set up the dependencies for Kafka for all of these plugins. So we're gonna install Kafka. And then we need to think about like, okay, what do we want to do here? So yeah, how do we configure Kafka? So we want to basically set up a topic that we're gonna post to. We want to set up an admin that would create the topic. And we want to create a producer that would produce events to the topic, right? So let's maybe have a look in the README for this. So we go here and Kafka. So also, what does Kafka give us? Like, what does the Kafka plugin give us? Streamlined configuration, admin client, producer client, consumer client, and Avro4K support. So it's really easy to register schemas using this plugin. It sets up all the abstraction for you. So let's see how we do it, right? So we have a schema registry URL, we define a topic, and then there's also this kind of common configuration. So we can just say, okay, this is relevant for all the clients that I'm going to define in this instance. So you create an admin, a producer, a consumer, and then, okay, we'll get to the consumer later. So let's focus on the admin and producer, right? So let's do it like this. Go here and let's define that topic, right? Event topic is topic. Topic. Oops. Named. Topic. Named. How does it work? Topic name. Yeah, topic name. Wait. I set up already a constant for this. So topic. This one. Okay, so now we have a topic. Well, we have a topic name. Event topic name. What is this? It's just a value class. Like this is also kind of a pattern that is good to follow. You know, the topic name is just a string, but we want to make sure that like we don't pass. We basically limit the amount of values that you would send to use as a topic name. So let's define. Now we're configuring Kafka. So this is where it gets kind of interesting. This is not embedded. What's it called? Configuration within a configuration.
Okay.
So let's go to the Kafka config, and we see here we have var. These are like kind of the things that when you see all these vals, this is something that like functions in the configuration class would modify. So the Kafka one is a very nested. Nested, that's the word that I was looking for. There's a lot of subclasses here, but if I look, let's just demonstrate it. So Back to the producer. So what do we do here? We go schema registry URL equals schema registry URL. This is stuff that I defined before already in the common module. And then now I'm going to basically invoke a function that is going to modify the configuration. So I go topic named topic. What's the name? Event topic name. Yeah. So now you see this. This is a function called from within the configuration. So you see Kafka config dot topic. What does it do? It adds a topic builder to the topic builder's value of the configuration. This is kind of, it's actually very elegant and smooth. It's something that maybe people need to get used to a bit. It's like you use extension functions on values that are internal to the, you see, this is internal. Like we don't want the user of the plugin to be able to modify this directly. We provide functionality to say, okay, add a topic to this, define a topic. Now, what's also cool is that we have DSLs. So when you do this, you basically say, okay, annotation class something. And when you give it this annotation, DSL marker, then what it does, it basically limits the places from which you can call this function. Am I correct, Compton? Maybe you can define this better for me.
Yeah, it controls the receivers of the same DSL so that you like basically wouldn't be able to interleave the different blocks of this DSL. It makes it kind of safer a little bit. But I think what is more interesting is this undocumented facilities of this annotation.
Yeah. This is
that are available in the IDE. So it kind of changes how IntelliJ starts working with your code.
So
If we could, yeah, you already have that. You already have a topic colored as yellow. So how is that? How is that possible? In fact, there is a color that is calculated. There are 4 buckets of colors that are defined in the settings that
here,
are
right?
calculated, and yeah, and the bucket is calculated by from the name of the annotation that you have created that derives from the DSL marker annotation.
Yeah, I want to show this actually. Where is it? In the editor?
If I could remember, so yeah, it should be somewhere in the editor.
Is there a color scheme? General language defaults. Color scheme for, I think it was in language defaults.
Yeah, probably. I used to remember that, but I just had a long
you
trip
showed
and
this to me
on the
before. Yeah. Okay, let's get to that later because it's just like for now we can see that like when we will look at other plugins, then we'll see that the DSL functions are colored differently.
Right.
So if we go to the topic, oops. So we basically invoke this function now. We say, okay, we're creating a topic, and we want to also configure this topic. So a good way to see also which values you are available to you to configure is to go this, and then you'll see this topic builder that I think topic builder. Yeah, partitions, replicas, replica assignments. So we just know, let's say 1 partitions and 1 replica. And that's it for now. I mean, these are also the default values, but it's just to demonstrate how we configure it. So now we said, okay, we're creating a topic, or we define a topic, and then we're going to define our producer. And actually, yes, so we'll define a producer here, and we say, okay, you you point to the Bootstrap service here, and we say there's many other things that we can say here. This is stuff that's common to all clients. But if I go to the producer, then we can see here all the stuff. And all of this is just Sisyphean work that I did of copying the stuff from the Java configurations from the Kafka, from like the Kafka code. And but yeah, so we can say, like, for example, retries equals 1 and client ID equals producer. Okay, so now we're adding a topic, we're defining a producer. Now we want to also register the schemas. So let's go register schemas. And this is kind of like fun to kind of use Kotlin to write DSL, which just is very kind of elegant, I think. So what we do here is we say, okay, I want to register my event class at events at events. Let's just rename this to events. So what is this? At is a extension function on, like, it's an infix extension function on a class that I think this can only be called from within the registration builder, I think. So if I actually try and do this, like, I don't know, here, then it's not available. So that's, I think, what the DSL actually gives you, because if you go here, then I say, okay, this is Kafka DSL, then all the functions within it must also use the Kafka DSL. So I think this is actually obsolete. So we say register schemas. We want to register my event at this topic, and we want to do this using some client, like so using basically gives you a way to configure a Ktor HTTP client. So it kind of like forces you to, to use Ktor. So you would go HTTP client, and then you can say, CIO or whatever engine you want to use. By default, it uses the just a default HTTP client here, which is I think that's actually based on what you have in the class path in terms of like engines. But you can configure it here with the CIO or with whatever engine you want. So let's just remove this for now because it's already defined. Okay, so now we configured Kafka. Let's maybe see if that's actually happening. So let's go here and configure Kafka. And let's just run the producer again. Let's just make sure that I set up the whole infrastructure before, so it's running. So let's go here and run the producer again. Okay, so now, if I make this bigger, so it's sending, but we see here that it also connected to Kafka properly. And I think if we actually look into Kafka, then we can see that we have stuff here. This is actually from before because I didn't clean it up, but let's see. Oops. I can't say for sure. Okay, so let's actually, we can also debug Kafka to see, but we can also look at the logs. Services. Containers. Broker. There we go. So, oh yeah, we're not actually sending the thing. So if we go here and to answer this question, how do we publish the event? How do we actually send the event with Kafka? Then let's do that and go producer. I think, wait, how does it work? We have access to the producer by going Kafka producer. Kafka producer. So basically, when you install the plugin, then when the plugin is available in the class path, you have this Kafka producer value added to the application. So we go Kafka producer, send, send, and then we go here. So what we do here is producer record, and we say topic, which is the topic name, and event dot time, which is string, and event to record. So what is all of this? And then also this is a async function that we need to get the result of in some timeout. And this is like a Java time because Kafka is a JVM. So that's what it is. It's Java. So what is this to record? This is actually using the Avro 4K stuff. So basically, you give it a generic type, and what it does, it basically creates an Avro record from it. And that's using basically, it needs to be inline and verified because it's basically you need to find the actual class of that type. Cool. So this is happening now in send event. So now if we go and rerun this thing, okay, now we look in Kafka. Yeah, now it's increasing. Yeah. Cool. Nice. Okay. That's nice. So now the question is, what if we want to have a multiple instance of it? Let's get there later, because in case we won't have time to get to the whole thing.
Yeah.
So because let's just at least go through producer, consumer, and client. So let's go to our stop this here, and let's go to our consumer. So the consumer is a server that has a endpoint here that it basically gets the latest event from the store. The store is just whatever, a set. Yeah, we configure the routing here, which basically sets up the endpoint, and we configure synchronization because we want to do that also. So the question is here. We have two questions. How do we get the events? Like the producer produces them, publishes them to Kafka. Now we need to do the consumer. So let's go here to on event. On event. What's the other question I have here? This is not this one. Yeah. So how do we consume events published by the producer? So let's just do that then. Very similar to what we did before with the producer. Run application. So configure Kafka, was it? Set up Kafka. Whatever. So install.
So that will be a different instance of Ktor application running a separate one, right?
Yes, we're running like a system here. So we have different applications, different JVMs, everything. So install Kafka. Okay. We could also do this in code. We're not going to do it now, though. But the example of how to do that is available in the README and in the example project. So now we want to do basically something very similar. So let's just put this guy here. And look here what we did. So we want the same. This maybe. And I'm not sure if we need to actually set up the topic. Let me just remember. No, all we need to do is basically set up a consumer and tell it what to do also. So we're going to go consumer, and we give it the bootstrap servers as we did with the client. So like these are common configurations to all the, so you have like consumer, admin, and producer. All of these are types of clients. So we set up the bootstrap servers and we say group ID equals group ID, no, equals consumer group, and client ID equals consumer. Now, what I want to do now, so we set up the consumer. Now, what we want to do is we want to tell it what to do, basically, because the consumer is not like a function that you call. It's something that just happens when it responds to events. So let's go here, consumer config, and we can set up how frequently we want to poll it. So let's say, I don't know, let's say this, but I mean, it also has a default value, which is default consumer poll frequency, which happens to be the same. So let's get rid of this. And basically, there isn't many tweaks that we want to do here, but we do want to define the handler for each event. So we go consumer record handler, and we say for this topic, events, we want to do on event. So event equals from record it. So what is this here? Like consumer record handler is something that operates on a, one sec, consumer record handler events, this, oh yeah, from record event. So we say this is what we're gonna parse it into from record, and we give it the record. So we say now when it's just because of the email hints the way it's configured. When I actually define it here, then I see what we have. So we have a consumer record, which accepts a Kafka record key and a generic record. This is stuff from Avro, I think. No, it's actually from the core.
It's from the Apache client, from the Kafka client, yeah.
Correct. Then we go record value. Yeah, so what did we do here? So we say we have a consumer, like we configure a consumer to have a record handler that what it does is upon receipt of a record, it parses that into the class. So from record, this is like the same kind of like a DSL that I added for this plugin that does the reverse of the to record that we saw before. Okay, so now we have the event, and what we want to do is on event. On event is the function that we defined here before that I didn't show yet. So we just add it to the event store and we output a log. So we set up Kafka, and we come here and we say, okay, let's set up Kafka. And now we should be able to see the communication happening between the producer and the consumer. So let's set up our consumer and the producer also. Hello, received. Like all of the stuff that we saw before, this is actually it responding to the events that were sent before. But now we see that, yeah, this is happening live. Right? 650, very fast. Cool.
Yeah.
So
that's a really cool, concise demo. Probably one thing that could be missing for people who are unfamiliar with Kafka is what is the consumer group, because it has to match for the sender and the receiver, and we have configured that as a string. So if
you're right.
you
This is
there you need some knowledge about the Kafka terminology. So if anyone watching this stream or the recording and you want to learn about that, it makes sense to refer to the previous webinar about Ktor with Kafka. There, Victor explained it really well. We are not going to dive into Kafka internals right now.
Yeah, there's an assumption here that like this is for developers that are familiar with the needs that these plugins are answering. But
Right.
of course, everybody's welcome.
But the way Ido explained it now is like and showed it, it's really like to the point. You have 2 points, 2 applications communicating over Kafka middleware, or they actually disallowed me to say middleware when I was talking about it. They say it's a append only log, distributed log, right? Not a message queue. So anyways, it's some middleware for me. And we send the messages, we consume the messages, and they are persistent and distributed, and that's the whole beauty of Kafka.
Yeah. So now we don't have no, we do have time, but let's try and get everything in. So now we set up the producer and consumer, right? Now we want to set up the client. So let's go to our client, which is here. And let's maybe close this and this. Let's stop this for now. So we have our client. Let's say we have a few clients because like we have like maybe a lot of phones that want to like query the consumer to see what happens. So what we have here is a client count of 2 for now. And what it does, it just in the loop, as long as it's active, it just in a frequency of 1 second, it goes, tell me what happened, like over here. So requests to the consumer to get to the thing. I think at this point we can actually run it and it should produce results.
It should receive something, right? Because we already have messages in Kafka.
Yeah. So let's just run this client. So okay, cool. Response is happening. That's all nice. So this is a simple system. Now, let's imagine we want to scale up, right? Like what happens if we want to have a lot of instances of the producer that produce the messages, but we actually don't want them to do the same thing at the same time. Like we want, let's say we have different servers, and at some frequency, only one needs to produce an event, which is a very common case. Let's say they're running a task to analyze something, and the first one would do it. So this is achieved with task scheduling. This is similar to like a Spring. What's it called? There's a starter in Spring for this.
Like so Quartz.
Here, Quartz is a library for the timing.
I think in Spring they have integrated Quartz.
Like, yeah, Quartz is using but Quartz I think is only the internal. Like I think that the starter in Spring that's doing the task scheduling is called something lock, I think, but doesn't matter because we do it in Ktor, so we don't care about Spring. So so here, how do we manage the tasks across multiple instances? So for this, we're going to use the task scheduling plugin. So let's go down here and go fun. So fun to run the right plugin applications. So configure tasks. And here, let's just look what I have in my notes. So we go install task scheduling. Now, how does this work? Task scheduling is basically you want to be able to communicate between different instances of your server to say, I'm doing this now. Okay, now we can do it. Like, so you basically lock using some data structure, some database, basically. I mean, there's more ways to do it, but like the implementations that I added for now are using Redis, which is a very common approach, using SQL, like JDBC rather, and using NoSQL, like MongoDB in this case. This is again kind of like following the common patterns that exist. And the thing about how I designed this, let's actually look at the source code for a bit. So let's close everything. And we'll go and look in task scheduling. So let's see how this project is structured. So we have the core. This is just the logic of doing the stuff. And then you have the different implementations, JDBC, MongoDB, and Redis. Now, the thing is also, the plugins here are multi-platform, so you can actually use them for, if you run a native server for some reason, then you can do that also. But then the limitation is that we don't have a native implementation for JDBC, obviously, because it's Java. But then also MongoDB, I think also I did just, let's see. No, it's on JVM. Redis is available in native, and that's cool. So this is kind of like maybe interesting look into Kotlin multi-platform development. We can see here that, let's see, it's going to be, I'll just show you the dependencies. So project common, get the scheduling core common. So we have this Redis MP client, and this is basically a multi-platform Redis client that I created. It's published separately, and this is basically using the creds library, which is a Kotlin-based JVM Redis client for communicating with Redis on a JVM. And then this library, so it's using this, and then it's using a interop with the C Redis client. So basically, I can show you the project later. I can add it. It's also available in my repositories. But basically, it just does the implementation for JVM is using an existing Kotlin JVM implementation, or client rather. And then for native, it's using an interop with C. So that's just like a quick kind of look into that. It's just we don't have a lot of time, so I just want to mention that. But basically what I'm saying is that we need to define the task scheduling. I don't like it when it does that. So we define the common behavior of the task scheduling. We want to say, okay, I want to have this task at this frequency, whatever. And then we say, okay, and this is the provider for this task. So we'll go with Redis. So let's just define here a task. And we'll give it a name, produce events. And the task is to double, yeah, that's fine. So we need to have a name for the manager that's going to manage this task. So we're going to go Redis manager name equals Redis. And then we go here, Redis manager name. Now, here we define a task. And this is using, like, we basically say, sorry, it's like this. We say the task is basically a lambda that does something. And what it does what we defined before, send event. Now we want to define a schedule. So this is using a cool library called Chrome schedule. equals seconds one every 3. This is like the DSL that like the cron library itself uses. Need to download the documentation. Problem with documentation with multi-platform clients and IntelliJ, I think, is sometimes happening. So basically, it says start with 1, do it every 3 seconds. And then we can say also hours. This is like a cron syntax, but in a Kotlin DSL way. So we defined what we want to do at what frequency, and we gave it a name. And we say that this is going to be managed by this manager. So if we go here, now we're going to define the manager. So let's go Redis manager name. And now we basically configure it to point to our Redis instance. So yeah, all of this is username. So I'm just going to copy it over. Yeah. This is like configuration that like also has default values, but we can configure it here. So basically we say how long, like at what point would you give up on trying to get a connection from the Redis connection pool, and for how long. Let me just go to the documentation for this. This is a wait. This, yes. So we have here post, port, username, password, lock expiration in milliseconds, connection pool in initial size, connection pool max size, configuration of the connection pool basically. And this is specific to Redis. And you have also configurations that are specific to JDBC and MongoDB. So let's go back here. Okay, so now we defined the manager. So now, to test this, what we're going to do is run 2 producers and see if they don't clash on running the task. Let me just make sure that everything is configured, because it's not. Configure tasks. So now we basically delegate this thing that we did with the plugin before, the produce events, which we also did twice here. We're going to delegate it now to the task scheduler. So the task scheduler not only does it, you configure the tasks there, you also configure how you coordinate the tasks. Yeah. Cool. The frequency is not used anymore. Oops. Cool. So this is the answer to this. And now we're gonna run our whole system. So this is gonna spin up 2 producers, different ports, different IDs, and the client and the consumer. Let's make sure that everything is stopped. I think it is. Run system. Okay, producer. Now let's
so
here.
now we have 2 producers and a client, right?
Yes. And now we can see here, and we also have we have 2 producers, a consumer and a client. So let's look at the timing on these events. 55, 4, 5, 5, 4. Yeah. Is it happening? So this is minutes. Yeah. So I think we are not clashing here. 16. Okay, yeah, because the frequency is every 3 seconds now. So basically 16, 9. Yeah, we don't have like messages happening at the same time. 16, 19, 13, 22, 25. Cool. And now the consumer is still doing its thing. and the client is still doing its thing, and that's because the consumer is also doing its thing. So that's all well and nice and amazing. Two more things that are common in systems engineering. How do we manage load on the consumer? Like the clients are sending requests to the consumer. What do you have if we have like 1 million clients asking? For some reason, we only have one consumer. Then we basically don't want it to overload the system. And also maybe we want to manage like, hey, you only get to do like 10 requests a second until you pay us or something like this. So for this, we're going to use rate limiting. As I said, rate limiting is a functionality that's out of the box in Ktor, but this is offering a more flexible way to do this. So let's look in our consumer. Yes. This is consumer. How do we manage load on this route? So the answer for this is that we need to basically we need to install the plugin for rate limiting, and then we want to configure it for this route. We can also configure it globally. So let's go here. Configure.
In the chat, there was a question: how many partitions do we have right now in Kafka? I think it's a single partition.
This is also configured in the partitions.
Oh yeah,
it's configured now.
So it's configurable.
If you want to see it in here.
Yeah. And also a very good question, I think. If it's a long answer, feel free not to answer right now. Maybe we can follow up on this. But Chris is asking, how does the consumer plugin handle shutdown in regards to losing the messages? So the messages, I think, are not lost because they are in Kafka, but it's the offset that is important, right?
That's a good question. We can look into it later.
Right.
I do actually want to know now if I got this one, and if I didn't, then let's open a ticket
and see. Like, Chris, feel free to ask in the issue tracker. There is a GitHub repository, and maybe Ido can follow up on this question in the comments to the video afterwards.
Yes, I will do.
Right.
So right now we were going to the consumer, and it's configuring rate limiting. Install rate limiting. Yeah. Rate limiting. And now there's different algorithms we can use. There's token bucket, there's a leaky bucket, and time window. So let's just go with rate limiter with capacity of 20, rate 4 seconds. And now we say type is going to be token bucket. So what's happening here? By the way, this is the DSL thing, like producer yellow. Task scheduling is what color do we get? We didn't get a color for this one. And for the rate limiting, we got green. So what's happening here is basically there's different algorithms that are available, and the capacity and rate have different meanings based on the algorithm. So basically, if it's a token bucket, then it can hold up to 20 tokens, and the rate of refill is every 4 seconds. With the leaky bucket, it's like, if I'm not mistaken, its capacity is the same, but the rate is the rate in which it leaks, like the rate in which it lets another request through. There's also the time window, but let's not get into it now. All is available in documentation. So we're gonna now put this in our module. And now we set it up, and now we want to basically apply it to a route. So, sorry, no, this is, yeah, we do that by, yeah, so we want to apply it to this route. So I think what we do here is, wait, I don't remember this one. So let's look in the documentation, because rate limiting, install rate limiting, rate limiter, get, oh yeah. No, yeah, it just happens globally unless we define like ones for, we can also define route specific rate limiters, but this one, it's global because it's unnamed. So because I didn't name it, then like this rate limiter is unnamed, then it's gonna apply to everything, if I remember correctly. So let's try it out now. I think I double did it, right? Yeah.
Oh yeah, yeah.
This, but it's okay. So consumer received event client. Okay, yeah, we're starting to see too many responses here. And then too many requests. And now we're going to see that after so-and-so time, it's going to be okay again. Should be. Okay, I think this is because I didn't also install the circuit breaker. So this is where the circuit breaker comes in. Like, because we have two clients here, I think we're missing the...
Right. But the idea is that when you connect with the client and client is slow, right? You cannot consume as many messages as you receive.
Like when I connect with a client, I mean, I can get the messages from the database. It always gets the last one. This is the API.
Okay.
Let me just start it up again. So nothing is running now. Run system. Consumer.
I meant just to recap the idea of rate limiter.
Yep.
Like, what is the use case scenario, right? The system produces messages. There is a lot of them, and now
they exist in the database of the consumer, but then we want to basically limit the access to the consumer. So we want to say that you only get to do like 10 requests a second or whatever, because we want to limit the load on the consumer, and because it could be a business thing, this decision also. This is how you you can do it, that this user gets to have this much. This is again all available in the rate limiting configuration. So basically, there's like so you can say blacklisted agents, whitelisted agents, and principals, etc. So you can say that like you, because you're a paying user, then you're excluded from this rate limiter. But then we can also add another rate limiter that doesn't exclude you. And yeah, the algorithms kind of like provide different behavior on, like, for example, the leaky bucket is more for flattening out the load of requests over a period of time. So in 4 seconds, it kind of like makes sure that it will always be like a constant rate of requests. Whereas token bucket kind of like allows bursts of requests. So like you can use up all your tokens and they burst basically. Let me install the circuit breaker, because this is the first actually, it's on the client. This is the first client plugin, because everything up until now was server plugins. But this doesn't mean that it's not applicable for the backend also, because you can use clients in your backend also. And this is something that like Spring also does with the Feign clients, like in the what's it called?
It's the load balancing, I think.
And load balancing is something else. This is more about like you define interfaces in your backend that then, like, for REST communication between microservices, basically the FAN clients
Right.
give you like an API to just, you don't have to set up the whole HTTP request and everything. You just define an interface. But in it, you can also define circuit breaking, if I remember correctly. So this could be useful for if we at some point like we would implement something similar, but I'm not sure it's necessary because it's much more fluent here. So let's just go here and look here in our question. How do we prevent repeating requests when the server is failing? So basically the point here is that, like, okay, we see we're rate limited now. Let's not like keep hitting it, and let's just wait until the system is better again. I mean, it's not only applicable for rate limiting, it's applicable for generally if you don't want to keep making requests to a service that you know is failing because it failed for a few times. So what we're going to do here is fun HTTP. Now this is something we put on the client. So we go HTTP client config whatever. Like, we don't really care about the engine. Setup circuit breaking. Install circuit breaking. Now we can say we want a global one, or we want one for a specific request. Sorry, we want a global one, or do we want one and we can define then different behaviors? So let's do like global. Let's say failure threshold is 1, or maybe let's make it 2, and then half open failure threshold would be, let's say, 5, and reset interval would be 1 seconds. Now this would be kind of like a generic behavior for the circuit breaker, but then we can say also, and I want also to register one that would be strict. And we go to circuit breaker name, again using value classes. Strict is this. The reason I put it like this externally is because we're going to use it later in the client, when we make the request. So strict would be like, I'm actually going to fail after 1. And I'm not going to try doing it too many times after I fail. And I'm going to wait for like 4 seconds until I try again. And we can actually match it to the rate limiting. Yeah, 4 seconds here. Let's do it even 5, because we're going to have 2 clients. And yeah. Now we go to the client, and what we do is, so we have, first we need to install it here on our client. So set up circuit breaking. And then what we do here is basically go request with circuit breaker. And we can say this would be with the global one or with the strict one. And now it's going to apply the circuit breaking behavior to this path, to the request. So let's look at our system and stop just to make sure.
Okay, so basically we have rate limiting now on the consumer side, right? And then we have a circuit breaker on the client side, and rate limiter will start pushing back the requests according to the strategy, and the client will get like a failure and the circuit breaker will be handling it, right?
Yeah, the circuit breaker will basically, once it sees that like, oh, it's failing, I'm gonna stop now and wait, and then try again. And if it's still failing, I'm gonna back off. Like this is the closed,
Mm-hmm.
open, half
Mm-hmm.
open behavior. So closed is when like
Okay.
the circuit is closed and requests are coming in. Yeah, it's
Nice.
the metaphor is here is for electricity.
All
Um,
right. Okay. So basically, what should happen here is like a resilient, or the result of it is a resilient communication between two, I don't know, entities, like applications, so that
mhm.
you wouldn't have like failures. Basically, you
You,
would
I mean,
retry,
the
right?
thing is you can handle the failure also because you get a failure either coming from the circuit breaker or from the client, from the
Mm-hmm.
consumer. Like, but the point is that you're not gonna make those HTTP requests. You're not gonna go over the water,
Oh yeah.
and you're just gonna
Mm-hmm.
be like,
Mm-hmm.
okay, I'm backing off for a bit. And so
Nice. Nice.
consumer is receiving events. The client is. I think I'm logging the stuff here. Okay, too many requests. Too many requests. Um, Wait, I think you are not running. You are running. Hello from producer. Let's see. I'm trying to figure out if this is failing at all because like it did work before. Too many requests, too many requests. This is the circuit breaker exception that we don't even need to log, but we see here that it's. Yeah, I think something's up. Like I need to see what I missed here because like when I set it up before, it was
Well,
actually
I
up, and then
yeah, I
the
can see
rating.
some messages from the circuit breaker. So apparently it's
Yeah.
reacting somehow.
No, the circuit breaker is fine. I'm just wondering why the rate limiting is not reset. Maybe
Ah,
let me look at the configuration of the rate limiter. Capacity 20, 4 seconds, token bucket. Let's make this faster. So now it's gonna be like I'm actually gonna add a token to the bucket every 2 seconds. And
mm-hmm.
let's run the consumer again. Now this is also going to be failing with the 404 for some time, or service unavailable. Yeah, 404. There we go. Now, okay, I think, yeah, okay. But this is just because it started now. Too many requests. So if you wait now for 4 seconds, yeah, okay. So yeah, now we can see that like, okay, you got one more token after 4 seconds, so you get to make one more request.
Mm-hmm.
Yeah, and this is the same for both clients because they both get the same allocation. If I would run them at different times, then like if I would add a delay between starting up the client, then we would see that they it would be different. Okay, I
Cool
think
stuff.
that's all the plugins that
Well,
we now actually applied.
that's an awesome demo. I think
Mhm.
we need to post a link to your demo repository afterwards, and so that the folks could actually download and play with the plugins and play with the demo
Yeah,
application. Um, Thank you very
I want
much.
to.
It's like, yeah,
Yeah, I want to also
yeah.
just invite everyone who's listening and might be listening later on. Um, like, there's still more plugins that I want to add here. Actually, there's a branch where I started doing the cloud stuff, like Eureka Service Discovery. So it would be really nice if people also want to contribute, collaborate, add any plugins they might have. Also, if they want to, I don't know, follow the same structure and repository and the workflow and everything. Everyone's welcome to contribute and use it, please. Open issues, find bugs. It would be really
Cool,
nice. It would help the Kotlin Puritans community.
cool stuff. Cool stuff. Yeah, and don't forget to submit your plugin to the registry once you feel confident, of course.
Uh,
Right?
I think I'm confident. But again,
Correct.
I would be happy if people use it.
Nice, nice. Okay, folks. Thanks everyone for coming, and thanks for your questions in the chat. I hope you liked the demo. It's just a very nice example of how you can extend Ktor easily, and the plugins are really useful. You can build interesting systems with them, with on top of Ktor. With that, it's over for today. And thanks, Ida, for coming. And have a nice Kotlin, everybody.